Anyway, so basically, Namdi, so today's date, is the time is now, 10, 9, 11, no, the date is, 11:17, p.m. in the OBINexus room. So, the time now is what? 23rd of, December 2025. So no police is here yet, but I've got this them recorded, limited files, anything I have to hold in this space and time. So you want to always hold space, first, never time. Depending on if you come if you come from space, you are if there's space for you, if you have time. If you have the time, what you have double the space, because double the space equals half the time. So you have to have half the space to create a time. So that kind of thing. Two half spaces. So, if you have half of a pi r squared, you have you have if you have the area pi r squared, that means you have, in the linear sense, two pi r, which is r, which is your 10%, 0.5, to the power of 3, which is 0.5, times 0.5, which is 1, 1 times 0.5, 1 times 0.5, which is like, 1.5. So you get 1.5, which is like, the trident philosophy of stability. But this video is really focused on the Insignia project. M for Mike, U for umbrella, O for Oscar, K for kilo, K for. So I'm trying to create some kind of still room for myself, because I'm trying to create a quantum computer. But this is my quantum interface. What do I mean by that? So basically, Mmuko Signal is my social media, but I'm trying to literally be in the physical space, hold the physical space I already have in my room, but it's kind of sucks, because it's not like a mad cosmos crisis. But I'm not mad. It's just my philosophy. So I'm not gonna do any math today, but I do know what I'm gonna do. So I'm trying to hold digital space forever, but in the physical sense. So what that means, so I'm gonna have my own still room, but I'm gonna have my digital still room. So the room is gonna be double the kind of, I get 15 square acres. So 15 divided by 3, divided by 4, 15 divided by 3. That's the ratio. 15 divided by 3 is 4, and 15 in time, and 15 divided by 4 is 3. This is not good enough. So the time, so if I have the time, for example, if I have 4 meters squared, 4 meters times 4, we get 4 meters times 4. We need 3 of it, which is show for the time. That is the space in the error. So 4 times 4 times 4. We have to flip it. That would be 4 times 4. This is good enough. So 4 times 4 times 4 will be 16. 16. Now 16 times 4 is what? 64. 64 space. And that's the XY is equal system. But this doesn't have a time. So this is 64. Because if I divide by 4, 4 divided by 3 is 4. So we calculate actually 4's cube. So 4 cubes, the power of 4. 45 power of 3. So 45 power of 3 is 64. Now we share 64 because get 4. We should get one negative 1, one negative space we all share. So the kind of negative 1 is the negative space we all share. That's kind of your Pareto model. So if you have 64 divided, so get for 12, 15 divided by 3. 15 divided by 3, that's 15 divided by 4 is 3, divided by 3 is 4. So 15 divided by 3 is what? 15 divided by 4 is 3, 3 and a half. Oh, sorry, 3 and a half. So 3 divided by 3 is 3 and a half. So you have some kind of space, some kind of fraction share, and that's 0.75. So that means you can get 0.75 times 4. That would be, let's see, because I'm trying to play with this. We can do trial and error, play with these numbers. But I don't really like playing with the numbers, so I'm just gonna show you how you can play with the numbers and do it. But I'm trying to give you the informal one for your framework, Namdi. Because I'm talking to you while I'm doing it, because you can pause the video. So we get we share a trident, a full trident of 1. So we share a fraction of a fraction of like a fraction unit in the space and time, so we never pop of 1 negative. So just like your breathing room, this negative space is very important to hold. So you hold this negative space at all times. In your physical form. Anywhere you go in the room, you don't have to touch any computer. You don't touch anything. So if you hold some of the space, you literally just have the space forever in your physical space. This room I'm trying to make for myself. This is my own still room because I need a space for my going to the places I want to go. Trying to put myself. I don't care about anyone, so I'm trying to see what they're doing in the medium. But I should be there to hold the physical space in that physical form. So this form I hold is a bubble pi. So I hold 0.75%, 3 quarters of the space at all times. Based on not structure. So, but this 4 quarters is sparse. So, get 3 quarters of the space, for space and the time. For the space and the time, the physical space and the mental space, literally for the computer to hold it. So that would be 3 plus 3, 3.5 plus 3.5 is what? 3 quarters plus 3 quarters is what? 3 plus 3 is 6, 6 over 9. That's one and 1 quarter, in the physical, and in the manual that's the same thing, 1 and 1 quarter. But that's what we preserved. I don't want I never want the space. I never need this space. It just has to be there. It's a negative space. It has to be there. That space has to be there. I never need it. I never need it, so it has to be there. So you kind of see what I'm trying to copy for you. So now this kind of saying, this kind of paper is very important to, um, digitize, because it's a negative space. So you get negative space, -1 space, but that's -1 squared. So the errors look, so basically it's imaginary numbers you're trying to compute. You try to keep, you never need to compute them, because if you compute them, that means you're operating on them. You don't want to operate on negative spaces. You want to keep the imaginary numbers in your space. You don't even even look at it, can be with the computers can be annoying. So you have to only perform. So you don't only so you should never perform classical operations on them. You're in a quantum realm. Because if you have a -1, that's -1 to -1 is like in the sense of, you get a surge -1. -1, square root of -1 is what? 1, I. And that is square root of, get the square root of it, let's get the square root of I. Then you get I, and it's an imaginary number. So this imaginary number is get I squared, I times I, which is like a -1. So you want to keep the area -1, which is space, which is the surge. So you want to keep every unit there. Even you didn't want to operate on one unit, because that can blow up when you have a read of that interpretation. It doesn't matter where you are in the physical form. You have to keep that space there at all times, like the unit model, everything. But, so what's next to the already comparing it so you get -1 times -1, that would be I, they get I times I times I would be a -1. Now that's my negative space, my full negative. So anything that can, for anything has to be a half, so your half. So you get -1/2. What would that be? -1/2. I think. So you get I times but I times I divided by 2 is what? I divided by 2. But what would this be? Would it be I divided by -1/2? Because this is I. So I times -5, negative I is what? Times I equals I. But that's I will have a half of I. So I divided by 2 will be what I need to divide. So that'll be just 1I. So one so that'll be I divided by negative I. So this negative space and negative time, I have to keep for the space. So I keep this unit there. So this kind of the signal I keep. So this is the measured number I keep. So I is a so E is what? What is the density? E is the growth function of I pi. So if I is a imaginary number, it's very for you. You have to hold that in the mental and the physical. So I is what imaginary number. Pi is a number. E is a oil is a density. So oil is basically you got E I pi. So I'm trying to literally show that I always have this space. That's why referring to I as identity to the matrix. So that if I fuck it up, I have to compute it now because Euler's identity. E to the power of pi I. So basically, this is a plus 1 equals 0. So I'm trying to keep this at a so e to the power of I. So basically, I'm going to calculate it here. Should give me e. So e is what 2.71828. But I'm trying to keep this to what the growth. So this will be 2. So in my framework, this is 2. So you get to number 2. 2 is the Calculs system here. We got a 7-1. So we can use a fractional model to compute it, but the 7182 18, but 2 times 2 4, 4 times 2 is 8, 8 times 2 is 16. So we try to hold the space of a trident byte, which is 8 to the power of 3 times, so you get 8 I. So we to hold I, which is I times I, which is equal to -1, a negative number, a negative space, that's 8 bytes, 8 to the power of 3. So 8 to the power of 3 is 8 times 8 times 8. So the space you hold is trident. So you get space you need, space you don't need, and space you don't want to need. But you get 23. All you need for you to be happy, Namdi, for you to be comfortable. So you get 8 to the power of 27, because 9. So if you get 8 to the power of 3, 3 times 3 is what? 9. 9 times 3 is 27. So 27 space negative space. So e to the power of negative 12. So if e is negative 27, e to the power of negative 27 is what we're gonna need as a foundation of your no need. You don't need it. It's there. You don't need. You don't want it. You don't want it. You don't even want it. You don't want it, and you don't need to touch it. So if you don't need it, you don't want it. If you don't want it, you never need it. You never want to touch it. So that's what you need. So e to the power of negative 12 is always identity. But it's always a number of growth of stable growth. Because so basically, if you have half of something growing, you grow. If you have something that's growing, that the nucleus itself is growing twice, so that's where it's like, if you have like if you put 50% for a month, you get the kind of this kind of thing grow. So if you put 50p in a bank for 10%, 10% of 50p, so you have £5. 5% of 10% of £5 is 50p, and you put that every month, because 1 month is what you work, and you only work for 1 month. One should be just listen. Let me do it properly. Let me do it properly. Hello, Oila, Mr. Oila. Oila, I love you. Basically, I'm trying to do this properly. So I got no pen to do it. Let me use my calculator. I haven't got my notes to do it because I don't want to do it here. Okay, Oila. So let me do it now. So let me do it properly. So I times I. So negative 1. Oh no, I'm just going to mess it. So you get this room here. So you get the space I hold here, and the physical and the metaphysical. So I have to hold this space, but I don't need to interact with this space. If I touch this space, that means I'm like, but I'm messy. So I even want to make this and try to. Okay, this kind of that I've done so far. This is my consciousness model. Now don't forget to talk about this right now. But you gotta do it because you're talking to yourself, and you're gonna be doing it, and that's why it matters to you. Should I talk about it now? Yes, it's very important you talk about it because it's kind of like annoying if you don't. Okay, so everything has the microservices model. Everything has what 8 sides as an octagon. Because everyone that's not in the consciousness plane has 7 sides. Basically on not my level has 7 sides. So basically they have 7 times 7. So basically they have 7 parts that form their consciousness. So there's basically there's a single point of entry at the corners, but because they can expand the horizons. But to expand your horizons, you have to actually you should have this corners, but this corner is your consciousness. So this is a circle basically, but it's an octagon because my consciousness is an octagon. But I'm saying people after someone's going because I'm transcending because I'm I don't want to give, but I'm just going to give them an octagon, but it's kind of idea there. So you got the space you have, but I remember everything in the past. It's not on the ocean, so I really hold a lot of spaces in my head to think. People don't really think that. So I'm not really gonna show anyone what I do, but this kind of stuff. So this is what I'm explaining. So the kind of model I'm saying of consciousness, you got like I know something, just myself. I know something. I know nothing. But that nothing is because I'm not telling you anything, and that's epsilon stage. So you see epsilon. I know nothing. You think I know talk to you. I don't talk with you. You don't know me. You don't see. You just see your face. But that face is nothing. Nothing. So nothing. But that's me fully conscious, not telling you anything. Looking at you funny. But we don't joke. We just idle. But it's an idle state of iota. So we do nothing. We do nothing. But I am here now. But basically, if we are a union, if we are together, I hold the space of awareness, full awareness, but you don't know that it doesn't matter what you do, you can't see that and then you get what a union, district, and epsilon, and you get what tomography. So basically the kind of thing I'm envisioning is this pentagon octagon is like 8 sides, that's 8 spaces, so you need 8 input, so it's kind of annoying. So this is why it has to be sparse. So any 8 input, any 8 data, it's like they share some state, there's some state that's an epsilon, and epsilon is the default state of nothingness, so you don't have to touch, and that's why it's very important to get that in your head, because you don't have to see that state even yourself nowadays, but people can't even comprehend it. because it's not in the frame of mind. It's not in the day of life. They don't want to think about themselves. They don't have the concept you do. So there's like 8 octagons, but I don't really think it's 1, 2, 3, 4, 5, 6, 7. I try my best anyway because I don't really want to care. And you get you get the first octagon, you get the second octagon. They don't say you can switch with it. You can switch. You can for me because you know your consciousness already. You switch with consciousness. I'm not being rude at him, but people can't do this. Damn. You can go from the being conscious to being unconscious. Literally they can't do that because you can do that. But just close your eyes. Just I'm unconscious. Because you remember the state of unconsciousness. To be unconscious. So that's the problem. You are really formalism. Yeah, because it's trying to get a computer to probe itself for solutions to active problems, this kind of problems. Because you're gonna be in that space, but people are trying to hack the computer. So it doesn't matter where you are physically, you want to be there on time for the meme. So if someone probes your computer, they get a relay systems because it doesn't matter how far you are, you're usually gonna be in space at that time. So you're trying to define some kind of dimension. So if you have if you have a cube, 8 to the power of 3, you share a volume 8 to the power of 3, length times width times height, and that will be your topology, your tomography. To go about the inside of areas. So, for example, if I send a wave, if a wave propagates here, the wave can pop one of my axes, one of my things. But I would know because if this pops in the physical and in the metaphysical, that means something is torn, like it was shared. But my brain is damaging, and that's what I don't want. So I'm really gonna die in that space I am. That's why my student is important. It doesn't matter who you are, you all share 4 states, because 4 states is a chemical stability for everyone. No matter what you have stability, and so you have 8 bits, so you have 7, so you maintain a space of 1, 7 plus 7 plus 7, which is like 7 plus 7 plus 8 plus 8. For every 7 hexagon, you have trident to the trident topology to the 8. Only topology matters. Only tomography matters. The area you all share. Because the area you all share is the same throughout. So that's the unit. So you get nothing and something. But you have to get something to get nothing. So guys, there's a problem there. So it's kind of like a geometric problem. So basically, I'm trying to answer some kind of ontological questions about myself, but I know the scale because I know people need ontology to this. Because ontology is about you. You don't have to space. Only you need to govern yourself, and that's why you can force your part to do anything. You can do anyhow. It doesn't matter how you do it. If you can make an improve yourself, let me give you an example now because you're gonna fuck it up in presentation. So we get 3. We're gonna try. We a quadruple constitutions. We get 4 states you can be in. But I can switch between any 3 states at a time because I have 2 pointers. So but the 2 pointers are very important. So what is the pointer problem? Why does the pointer problem matter? So basically, if I'm actively switching consciousness states, I'm switching personas, I'm switching abilities, who I am. What would that mean? So since you have your linear sequence, you have a linear sequence of instructions. So for one time you hold 8 bytes, 8 bits. Every instruction linearly an array, so you can process them as a row. If you can put them as a row, you can put them as a column. You can if you can put them as a row, you can put them, if you put them as a column, you can put them as a row. But you want to have the maximum one for the start with, because that's basically you have the minimum size. So the minimum would be 8 bits. 8 bits equals 1 byte. 1 byte. So 8 bits 8 squared will be that'll be 8 squared. That'll be 16 bytes 16 bytes per one instruction at a time. But you try to flip this. So you try to say I can start here, but because I can start here, I already know I can start here. So I start. I want to start. I just want to make sure I do it properly. Oh no. Basically, I'm trying to mitigate relay attacks to my consciousness. No, so basically, whenever I try to log in, I didn't want to my computer. Guys. So basically, I'm seeing this 4 tomographic states of consciousness, not topological, tomographic. That's what I should be concerned about. Nothing more, nothing less. So what do I do now? So we get 4 tomographic states to consciousness, and that's basically 8 times 8. Because I know I'm gonna be able to get 8 but the area is 8. The area is only 8. So you get the edges already, you get a signal. So it doesn't matter what is a relay signal. You have to understand where you still actively fix yourself. So you get 8 bytes. 8 bytes, 8 times 8 times 8. So you also want to be in a live state. Basically, if you're alive, you're dead. So you want to know the state you are alive. You're gonna be best in because you have some. You get 8 bytes, 8 times 8 cubed. That's 8 cubed. That's 8 cubed. Sorry guys, I'm trying to do the math now because I have to do this properly. I'm trying to do it's the power of 3. So you want to know for 522 bytes of memory you need because that's 8 bytes. 8 bytes of memory. If you get 522 bytes, now you get in space and time. In space and time at a time. So at one time, you will need at one time you need one space. Oh, that is allocated 512 bytes. 512 bytes. So basically, you have some kind of polarity you gotta define via the pointers. For example, if you hold two spaces, you're really allowed to run on two spaces. You get 500 two spaces. That'll be 512 plus 512. That'll be what 4. Basically, at the minimum will be 512 plus 512. We do basically 2 2 2 plus 2 is 4. 2 and 10. That's you go to 124 bytes of memory. That you can at the minimum we will share at the union, and so we will share that at the minimum disjoint and intersection. We all share. We don't really get much to share. And then we get 512 bytes. 512 bytes. 512 times 512. That would be 512 times 2. 512 times 512, and that would be 264. 144 by 262,144 bytes of memory. We'll share. We can share because this is a local maximum. This is one that I have that you can never know. You should must never know. You know, but basically, there's two things you can do for every day. Two things you have. So that kind of idea. There, every two input have two output. Because you have two operations you can perform at one time. Because by the time I see, it's not the time you share. So sometimes defined there. So you get 512 bytes. So tomographically, this would mean the area of area two space you share at one time. I will need the area to be 512. So basically, any space I take 226 bytes should only allow me to have if this is log n, this is log n. This is log n. The time has to be O of 1 for me to keep that space. So, because the space is always there to resolve. So don't mind the algorithm. So the algorithm is doesn't try to define. So I always have some kind of thing. So I have to get the time equivalent in space. The time so the time equivalent will be the time it uses at a time. So that will be a log n time times log n time. That will be equal to 101 time. Or I can get 1 over log n time. Because if you get time first, you get log n time times log n time. But if you get the time divided, that'll be log n time divided by log n time, and that'll be 01 time. So my log n time will be 01 locally, and that's what should be allowing locally first prioritizing. I shouldn't be prioritizing because my one I should be prioritizing. And then if I get log n times the place you hold, but you can interact with me. It's annoying. So he has to. That's why it's tomographic. I hold this kind of space, but it's mosaic. So I know this space, but I can see space. So I'm gonna explore this. This is what I'm saying. So it doesn't really matter what you do. It still has to preserve itself, its state of execution at one point at one time. It doesn't matter. So the problem is that the language. I'm operating tomographically because tomography is about the area. So the goal I'm trying to do is basically if I walk in to my storeroom and I don't want to log in, the computer just says that. So listen, I just think because if I walk anywhere, my coach, I don't want to be able to log in to something that can literally. I don't want to press start. Maybe I'm arriving. Maybe I'm being hurt outside and I go to my storeroom. I get security, but security doesn't mean security inside. So basically, I come from access inside to the storeroom, but I'm not even danger. I don't even need the food. And this kind of thing I'm trying to put through. But the food doesn't need to be there. It used to be like a cinema room. So it's like a cinema room that can go to 4 dimension for the relay. So relay because there's no locks involved. You just have to measure the waves of the Fourier series on the transform via the Lapis, the left rotation Lapis. Because if you parameterize the left, if you have 2 left hands or 2 left leg, what you can walk. You can walk, it's still walk. It doesn't matter how you operate, because the idea is that two left operations two left, two anti-clockwise. So 180 minus 100, negative 180, so negative equals a positive. You can also still learn the right row, and you can still do all the right operations. That's why you see negative spaces, negatives, everything. That's what the Lapis model happens. I'm not gonna do it today because I'm gonna try to do it, but I really know what I'm saying because you have to have if you have two left copies. So okay, let me give you an example. Say you have a copy, something called a copy and a touch. Copy and a touch. So yes. So if you copy an artifact, copy a file, in the right one, okay, it's two left. If you have two left copies, what you're reading it twice, or you see you're reading. So if you have two left copies, operation CP in the terminal, two left copies. What you're gonna do is read it twice. Read it twice. So you read two read that, or you name two reads from two, and you have two R. But two R. This is why. So if you have two two reads, your performing run implicit right. Because that's basically the buffer stored to some kind of temporary storage, but that temporary storage has not been created. Fully created, so it's literally trying to create a space it doesn't need yet. So that's what it means. So if I'm polarizing left, I'm looking at myself and stuff because I'm like so if I'm facing right, I'm trying to look at someone else. But if I'm facing myself, I'm looking left. So it's like I'm looking at myself, but I'm looking at myself right now. So that's like me in the future or in the past or in the future once you do something. So basically doing something, actually trying to do something, but I'm creating the space to do it. So basically that's the idea. The left represents the left rotation. So left, root, right. Let me just give you a tree model now before you fuck it up. Read or write. Read right, write or read. SQ. So you got to read right. Right. So you only read right, and that's a nil. So read right nil. So if I read something, I'm writing it. So I have one read. For one read, I'll submit it. This is very important. Don't forget this tree, Nandi. This is a self-balancing tree. So it's an algorithm so if I have one read of a file, I'm writing it, but I'm doing some kind of operation in it. But I'm not creating. So it's read write create. So basically it's trying it because basically. So okay, let me do it again. So you have like so actually let me do it again. Read, write, execute. So read, write, execute as a create, destroy, destroy, and you can choose as a rebuild, or break if it breaks, and if you want you want create, destroy, read, build, break, and create, destroy, build or break or what repair or renew. So this is what you're trying to solve. This kind of very important problem. Because you're really smart now, you have to define it structurally now. So you have to have some kind of a log or one memory segment, something that can only be allocated to you, delegated to you, but not when you're crazy. Apparently, let's just go here. You never want that to be craziness, because you're trying to prevent yourself, prevent the community. But it sounds kind of crazy, but there's a community there. So let me do it properly. Genetically, this will be tomographically layer. So basically, you're gonna have the area inscribed into your local system, but all the other, but you get your local maximum space, and then you get the space around you, that's outside. But you get another space, basically try to give as much noise, give as much noise as possible, because you're controlling the space and time. So it doesn't matter. Basically, you're trying to send signals in space, but trying to get space to get back to you. But you don't want their noise to be your signal. So you want to ensure you have full social. You get no signal. You want to give them no signal. So no nothing. But you can propagate because basically mine's reality. I can send if I can send one terabyte per unit. Basically, if I want to clear my TM, like basically, the terabyte is what? How much is a terabyte? How much is a terabyte? Okay. So this is more my computer meant to do. I have to do it properly. A terabyte is what? Guys, I really don't know how much is a terabyte. A pegabyte, a terabyte, terabyte is a petabyte. Just give me what a terabyte, guys. So basically, we got 1,000. No. Okay, basically, I don't like this no more. Huh. Does anybody own a polar petabyte? No, Namdi. Okay, Namdi. Yes. So basically, yes. So the terabyte is the chemical state of it, but I want to get the yottabyte. So we all share a terabyte. Anyone can get a little terabyte because it's 1 to the power of 4. The force of the conscious because everyone can get it because it's chemical state of it. So what I'm trying to do is I get a TPM clear operation, but you don't define the clear function. For example, you got a terabyte per unit clearing model. So the unit you use is local space you share, which is like your room of 75%, 0.5. But this because you fragment it, you can't observe anything, you can't get anything from information. It starts to look wonky. It doesn't matter the data, you don't get anything, you don't give them nothing. That's the solution you're gonna get. So I'm trying to define this properly with a Cisco model, because we everyone shares the 75 on the 1/2 of something and everything, one half of everything and nothing, via the medium or electromagnetic space or them, via radio waves or radiography. So rent money is visible under X-ray glasses. Rent money is visible under X-ray glasses. Basically, this is what I'm saying. So everything's radio wave. Starts off as a radio wave, but I don't really believe this. So you get I believe this because you get a radio wave as an electric signal, or what? Electric wave that's wireless, or electric wave that's microwave free forever, or radio wave and a microwave. Radiography. So you get radio waves first. In our nose, but that's we get red shift. So anything moving away is a radio wave. But if you get enough red shift, it's very important to understand. You can get information. So you don't want any noise in the system. So basically, I'm trying to make this properly because if it fucks up on me, it fucks up everywhere. Because it's gonna not work. So ridiculous is so you want everyone to see red, never blue, never like a red, green, blue, never blue, never green or blue, because that means that you are not doing it. So you want to see them. Every time you see green, they get more noise. Every time you see blue, they get more noise. So what does that mean? So you have to develop a file function that gives them only noise. So if there's a filter, if there's a flash, if say you're trying different function clear that clears a terabyte per unit. So every space is per unit. So basically this function works like this. So you get so if you try to just destroy a terabyte or nuke a terabyte, you destroy everything in the disk, but you're trying to nuke the disk. But you can't nuke this safely. So what you're gonna do is literally have a noise start nuke. So what this means, you take your time and basically you want to clear everything. So before you start clearing, you create a space, you create reserve space in memory to clear everything. But that'll be some kind of business human. So that'll be 8 bytes, 8 bytes of memory. But that 8 bytes of memory is not good enough to do it because that base of is what you need to do this thing. So 8 bytes of memory, 8 to the power of 3. It's 27 bytes of memory to clear. That's what you need. That's the unit of space you need to start destroying everything. Like me, that's like you saying, let's just write in the command the touch. So the touch command is what you touch something, but you can touch something to destroy it. So for me to destroy them, the touch they destroy it. But if I touch something, I nuke it. So because I'm trying to nuke the whole disk. So basically, I got my I got my disk there. What am I got? See that disk, Namdi? Namdi, make sure you get it. That kind of disk is there. So don't touch it, Namdi. But you can touch it digitally, in digital waveforms. That's how you try to nuke. So you can destroy everything that's there. That's even how the memory organizes itself. So you go to just touch that file in that system and clear everything. So you can have your own system, split your quantum system, even how the memory alignment is. I don't really care that. So that kind of thing. What's it called? It's a WD terabyte. You're trying to nuke it. But trying to nuke it safely. That's the idea. But if you have b squared or b squared, that means the area is blue. So it's kind of a color encoding system. Red, green, blue is digital space. So basically you're trying to ensure it's all decentralized. For example, if an artifact has a problem tomographically, he has to able to fix itself. He has to send only one signal, and so someone can start getting it to fix it, get it to fix it. But it should be fixed itself by when it's done. But if it sends another signal, it's like someone has to fix it now, before it starts to fail. And degrade everything. So literally, it's a decentralized computation of signal operation. So basically, you gotta define a walk cycle or some kind of a speech cycle. No matter where you go, you kind of like able to know the system knows you are there. You hold that space, whether in the physical and the metaphysical, because it's a room that you are in. And a bubble. This is when you eat a burger or something. So blue or blue squared equals one orange. Two orange. If I see two, so if I observe two blues, that means that's one orange. That means you are in danger. Danger. But if I observe a blue on myself, that means I'm in danger. One blue. So that means that someone's observing one your blue. But if they've observed it twice, that means they see orange. That means you're in danger because it's color encoding. But that blue means you're in danger because that's you. That's you to the world. Basically, it's an encoding system for this. And you get two blues equals two blues or blue squared. This means this space is dangerous. This area is just one area. One space is dangerous. This space is dangerous. This is danger in this space. What? Two greens. Two greens means what? Two greens. Two greens means someone I know. Someone I know is in danger. For me. So two greens. One green means I think someone might be in danger. I know someone might be in danger, because I observed this state already. But because this guy's showing green. Okay, so basically green is safe. So you have a green area. So if everyone is green, that means we all safe. But we can shift between hues. So if I'm green, that means I'm safe. But if I insult you, you're what? Light green. So you are like a but I want to change color, but you get a light green or you get a solid green. So basically, because if someone insults you, that's like your system glows white green. But this white green, if you're all green, we all see green. We're all happy, but it's all green won't be one. Green lights. And then we get a red. Red is like danger. Red means like the system's failing. So basically we have infinite precision. And everything's gonna blow up. Basically with the competition, everything's failing. So if I hold a space of two red, red times red, that means I have my pi radar. My area is dangerous, and I have to start fixing everything. But maybe I'm not a problem, but I have to start going. So I can if I turn on if I then first of all if I have a switch and I turn it red, that means I'm trying to do something. I know something and I know I can fix something. But I do if I then zoom if I zoom in once my red squared. If I have the red squared, that means I know my space. That means everyone's listening to me, because I'm basically because it's only me in red. I am the one. This everyone's in my space. Because everyone's looking at my space, red squared. But if I then look at myself, I am the node in the system, or my red becomes my node, my tomographic node. That means I want to actually do something. This can be good or bad, right or wrong. Which is why the probing of the system matters, because I can do right or do wrong, but I can say I am right. So basically, everyone must involve the system. Everyone gets consensus to do it. Tripod consensus to do it. So literally, it's kind of annoying because I'm trying to define it properly via the single system. So it doesn't matter how you walk, how you talk. The TPU clear. You basically, if you clear 8 to the power, if you only need 8 to the power of 3 to have some kind of a destroy new command, which is a clear. Which is like a new command. For example, 8 to the power of 3 is 8 times 8 times 8, which is 16. This is about 16. So if I need 64 bytes of memory, 64 bytes of memory, 64 bits of memory, or 8 to the power of 3 bits of memory, bytes of memory, that would be the same memory I need in the XYZ dimension, and that's kind of the kind of thing minimum I need. That's why it's based on my reference point, because I don't want anybody else in the 4 dimension clear having an extra space to clear it. As a policy that you have to just lock that down. You lock it down because you reserve it forever. You don't need to lock it down, just record it as a policy. So that's kind of money trying to do, because it doesn't matter where you have a row, color, right? The row or column conjugate, it just has to be there for that only you. That's 8 to the power of 3, and that's like a byte of memory you need at all times. And that refers that byte is like the only command you need. So if you touch something, you're literally just trying to either touch it once to destroy it or nuke it. When you destroy it twice, That's a nuke. But you can either what write to it, write to it. You don't want to ever write to something. You just want to observe something being destroyed. Like you just touching something, you touch death. You know, when you touch something, you touch death. So if you touch a file, if you touch like a folder, dot slash dot slash clear. So let's look okay, look at so if you have a folder dot slash get keep dot slash keep dot keep so you get different diagram. So dot keep a folder. This keep folder keeps everything. Okay, let's do this dot keep folder is a file that you want to keep dot keep. But in this dot keep you have two folders, dot found and dot what dot lost. So you should just write everything in this basic. So but there's a kind of trying folder because this folder is very there. So dot keep is you keep everything. Dot found means you find everything is the found. But dot means you find everything you don't know it. This only thing was so you find everything found is there and you know it's found. Everything dot lost is like it's lost and found, but you keep one of them. But you're trying to nuke everything. So what would you do? So you just touch this file and destroy it. But you have some cheap use. So if you have to do some, so everything for all the terabytes here, I try to get to quadruple. So it's the power of 4. So you get all the memory to the power of 4, 1000 to the 4 to the power of 4. That's terabyte. But you want to touch everything. You want to do first is touch death. So touch, I used to touch what? Touch keep. And you run some command, relay command, some command. So you have this for the dot slash forward slash dot keep, and that one dot keep. We want to keep some command arbitrary from the system. So we want to catch that. So let's call let's call it death. Nil. You should call it void pointer. So we need to nuke. So this nuke is like destroy everything. But you don't have the. It's like your code. You have to have some password here. So it's a password later. If you destroy this interface, you have to give some kind of signal. You don't want anybody to nuke it, for example. So you want to be there to relay that signal, but you don't can nuke it because you have to touch the file. You have to actually touch it. You have to run it. Actually, that's the kind of idea. So it's like dot get. It's like get. Get raf. We're going to show you from. It's like the touch. If you go to dot get, and you have to get you see if you like a touch dot get and you press tab. You can see all the files. You don't even to see the files. Usually, in my framework, if you touch dot keep all the folders, you can't even observe all the states because if you don't know what the state of the keep folder is, you don't know what's gonna be in there, and it's truly hidden to you. Because you are not the authenticator, you don't own the system. Which I'm trying to make. So it doesn't matter how much blood so basically the state for you is null because you nil. Because you didn't create the state, you can't enumerate the state. And that's what it matters to me. So that's what you're trying to do. You didn't create the state. You did not create the state. You will never be able to find the state. Enumerate the program folder state. All the files that are there. So for you it's impossible to even know it's there. Because you cannot get it. So that's the function I'm trying to provide. So let's end the session here because it can get a lot. So what's the problem now? Problem define a tomographic functor over the set of two right lapis, two right half lapis, to one full left lapis, which is like the tomography layer of two left, one row, and now I'll be trying it two left lapis, or integral lapis, for the tomographic function that keeps that holds epsilon, a set of epsilon bytes, like a series of a trident series of a series of epsilon bytes, via ontological reference of point of reference, via dual pointer series. If I hold two spaces, if I hold the free spaces, I should the people should only see half of the time, because half of the time will give them no information to run execute arbitrary code on my Mmuko system. Basically, and they'll be touching that. They'll be touching nothing because the file doesn't exist to touch. So there'll be no arbitrary command you can construct via auxiliary patterns. Basically, things commands you can run, functions you can define ahead of time to execute some sort of operation. So that's what I'm trying to do here. So this is your false statement. It's very ugly, but that is formalized. So again, you are trying to ensure that anything after your space, anything after your field view, doesn't have a hard lock. Doesn't matter. It's shielded by radiation, by the radiation of the noise, the noisy system, the noisy world. Because being in the meter, in an alien world, it's like literally being in the people that are really smart, people that are really smart, but at your level, and that's what you're trying to mitigate. It sounds kind of crazy, but it does work the way it does. So two left rotations are your one because if you rotate once, you're either right, or if you rotate again, you're wrong, but you don't know what you're gonna be. So you get a probability of 50-50. So that's why you have the lapis, the left rotation of two left rotations as kind of integration state. Because you need four right rotations, which is four integration to make your full one full. Okay, thank you guys.